Hello, everyone. This is Brad Burwald, a product manager at Morningstar, and thank you for joining us for today's webinar, which is on the advanced features and capabilities of the ProStar controllers, and that would be all the models in the family that we'll be talking about today. It is presented by Rob Rallo of Solar System Services, and of course hosted by Morningstar. So Rob and I will be teaming up to cover the presentation today, with Rob taking the bulk of it on the system expertise. And just a few things to talk about before we get started. Please, if you would like to submit any questions, you can do so using the GoToWebinar question form, and I'll be taking a look at those as well, Rob, and we'll be addressing a lot of those at the end of the presentation. So please type away, and we will select as many of those as we can, and hopefully you'll get a lot of them answered during the webinar. You'll also see that there are handout file attachments also within the GoToWebinar file structure there, and you are welcome to download the slide deck to keep for yourself. And also this presentation will be recorded, so it will be available soon afterwards if you'd like to watch it or share it, and is typically also shared on Morningstar's YouTube channel. Okay, so with that, I will go ahead and get started. I'd like to introduce Rob Rallo, President and CEO of Solar System Services. He is a friend and someone I've worked with for many years, so really happy to have him join us today. He has 30 years of experience in off-grid power systems, and we've worked together with a number of different companies doing system design. And he covers system types that include, of course, standalone solar, dedicated off-grid systems, hybrid systems, those would be with mixed renewable energy sources, and also UPS, uninterruptible power systems and backup. So with that experience, he also is an active member of the IEEE Standards Organization, and you'll also see him referring clearly to a lot of how off-grid is done in the IEEE format, which is an excellent practice to follow. Services his company offers are system sizing and engineering, providing design assistance, including the bill of materials and drawings, material sourcing and documentation, and a variety of technical writing and specification help. And as you are seeing now, also a lot of experience in troubleshooting and training as we bring you this training today on the ProStar family. Okay, so what the discussion will be today is going over the ProStars. And this is a product that's been through both PWM and MPPT variations, as well as multiple generations, since it's one of the classic Morningstar products that dates back to pretty much the inception of the company in 1997. We'll be talking about similarities and differences between previous generation and new Gen 3 features, which sometimes are not always well known, but they'll be covered today because there's a lot of enhancements. Specifications, of course, between PWM and MPPT, some of the differences between those two products, and then a detailing of both basic and advanced features that are covered for these products today. And you'll be seeing that detailed in lots of graphs and data examples. Some applications examples, because you've got to see the features at work and really applied to real systems to understand the benefits. And then finally, questions and answers, which, as I said, we'll be taking at the end. So just a brief intro here on a few items with Morningstar. If you're familiar, we like to think of ourselves as the charging experts with our family of solar charge controllers and inverters. We have over 4 million units deployed in the field since 1993. So we don't just say it could or will do this. We can say it's done this because some of them have been in the market for decades. We sell in over 100 countries, and we have specific applications that we work in, including residential and rural electrification. And rural electrification being, what we'd call solar home systems, including a very notable project where we provided power to 200,000 homes and 3,000 community centers throughout the country of Peru, affecting over 1 million people by providing them with energy. Commercial applications, industrial, telecom, and oil gas are also applications we focus on. And then also the mobile market, which includes mobile, RV caravan, marine, and even agricultural systems. We have an extremely diverse product line with all power bands covered, as well as a variety of MPPT and PWM, and even some application-specific products, such as mobile, dual battery charging, and lighting control. And we like to talk that we have the lowest failure rate in the industry. And again, we can back that with our data and our millions of installed controllers. Okay, thanks, Rob. The two product series that we'll be talking about, I also want to cover is that in order to better segment the products, we have both our professional series and our essential series. The professional series is what you'd expect: mission critical applications, industrial, better features and performance designed for the needs of that market, a very low failure rate, and really the gold standard for all of those applications that I spoke about. As we do also address rural electrification and more cost-effective markets, we also offer the Essential Series, which is a similar topology of circuitry and 100% Morningstar product, but a little more of a reduced feature set catering to smaller projects and those that are in the price-sensitive industry. Okay. So to talk about the ProStar MPPT and Gen 3, these products, as I said, have really been flagship products for Morningstar. They cover applications of up to 1100 watts in PV charging capability, and that is continuous. And as you have seen the products evolve, we like to add new features and new application support, but also keep a product that is familiar enough to you that the design is something that you can work with over the years and be able to count on it for years to come. It's a fanless design, which generally means no moving parts, no dust and debris is sucked into the product. We use a generous heat sink on the back of the products, and also very low parasitic load because we want to get more of that power from the PV into the battery. A note on data, which will also be a featured topic of this presentation, is that with our EMC product, a lot of the products that are out there that have already had Modbus compatibility baked in from the start also gain the capabilities to communicate on IP networks. And as you'll see in telecommunications, security, and other modern off-grid applications, IP connectivity is critical. So with the EMC added to these products, you can see that if you've got an existing networking infrastructure in place, whether it be telecom or the digital oil field or just remote monitoring for renewable energy, you'll be able to communicate with the products. And that includes any of the products that have our serial communications. So Modbus, the de facto standard for automation and control, also used by the solar industry already, and SNMP provided support for the IT and telecom industry. Okay, next slide. And you can see a quick example there with the ProStar integrated with an EMC. It finds itself at the heart of the system there, seeing both battery, solar array, and various loads for those applications, and then connect to the internet through a router. And then you can get the management in place through a network management system, a web browser for a web page interface, which most people expect on a lot of products, or SCADA integration. And that also allows you to use the MSView software that Morningstar provides to remotely collect data, change settings, and manage the system. Okay, so that is a bit of our overview. And with that introduction to Morningstar and our line, I will hand it over to Rob, who's going to go into detail on the ProStar family. Take it away, Rob. Thanks.
Brad, thank you for that introduction. Let's see. So let me start with, I'm just going to start with a brief history background here on the ProStar. The ProStar Gen 1 actually came out in the mid-90s. And it was when Gen 2 came out, I think in the 2000s, it was very similar to the Gen 1. And as a matter of fact, the only real difference between the two was the red stripe on the dark gray case. Otherwise, they were similar. I think they added a few extra LEDs and a few extra things. But when Morningstar came out with the Gen 3 about 5 years ago, there were a lot of additional features added. And for me, the whole purpose of this webinar is for, hopefully at the end of this webinar, you've learned something new about the ProStar Gen 3 you didn't know. That it can do something you didn't know it could do, or had some feature or some piece of information, or just something new about it. And if you learn something new, then I feel like I've done my goal of this webinar. So anyway, some of the similarities here are they're either 12 or 24 volt. They come at a 15 amp or a 30 amp current output to the battery. They both have a maximum input of 60 volts only. Again, this is for the PWM version. We'll talk about the MPPT in just a minute. Okay, which means they'll work with either a 36 cell module for 12 volts or a 72 cell solar module for 24 volts. Again, the same operating temperature of -40 C to +60 degrees C, and they have the same package. All the screw holes are in the same place. So the nice thing about this is whether you're replacing a Gen 1 with a Gen 2 or a Gen 3, they all have exactly the same form, fit, and function. So they're all reverse compatible. So that's something else to have. So if you have an old Gen 2 that has, or Gen 1 that has finally died after 10 plus years of use and you're looking to replace it with the latest and greatest, then you can go ahead and put the Gen 3 in there. Of course, I think Brad's already mentioned this, all 100% solid state, no fans. There are metered versions as options. And they do have electronic protections for overload, short circuit current, reverse polarity, stuff like that. And they still have the 5-year warranty on the controllers. Okay, let's talk about some of the differences. The Gen 2 had no meter port. That means you had no remote meter option and also no EMC1 option on that. So that's a huge upgrade. It also meant that you could not plug into it with a remote computer and make a whole bunch of changes or look at things, which would include data logging that we're going to go into detail on, or also custom settings we're going to talk about as well. The Gen 2 also did not have lighting control, and there's a full feature of lighting control functions that we're going to go into in detail, as well as the possibility for firmware updates you can do. I'm not going to go into that one in detail. It also allows for an external temperature sensor that just has some screw terminals on it. The old version, you had to solder to it, and that became a real pain in the neck. I had a couple of customers that had to do that, and they were not pleased to have to do that in the field. So just being able to have some screw terminals made it a lot easier. And also a whole bunch of load control as well now, a whole bunch of features there we're going to go into detail. So there's some major improvements with Gen 2 to Gen 3, and we're going to try to get into some of these in detail here as we go through the presentation. Some of the other differences is there's now a protective cover that has been added. On the old version, if there was a noise problem, you actually had to, I think, cut a trace on the board or do something else. It's a real pain. Now it's just a dip switch setting. And I'll go into some of those noise reduction things later on, although that's not really too much of an issue anymore. But again, I'll just mention in case you do have a noise problem. Again, we have some enhanced self-diagnostics and testing. It is now also compliant with IEC 62109. The old version wasn't. It's got increased search capability. And again, it's got the display on it is just way better. It's just, you've got keypads that makes it more user friendly, and we'll go into some of that in detail over the old one just had a display that just scrolled. So you got three things. You got a rate current, load current, I think, and battery voltage, and that was about it. Not real helpful. Now you can actually go through and even change set points and do all kinds of stuff from the keypad, and we'll get into that in more detail again as well. Okay, so that was on the PWM. Let's talk about the differences briefly between the PWM and the MPPT version. The MPPT version is a little bit bigger. The PWM is only 6 inches by about 4 inches by 2 inches deep, whereas the MPPT is quite a bit bigger. It's 2 inches wide by about 6.7 inches high, and it's a little bit deeper at 2.8 inches. The PWM version obviously is just pulse width modulation, whereas the maximum power part, the MPPT version is maximum power point tracker. And I'm not going to really go into the difference between the PWM and MPPT in detail. I think Morningstar has done enough webinars on that. I think at this point, most people already know differences. If you don't, then I would suggest looking at some of the other webinars that Morningstar has on their website, or some of the tech notes or things like that that are really available already on the differences between the PWM and the MPPT in terms of functionality and how they work. The MPPT version also has an optional wiring box, but the key here is, and the thing I really want to highlight is, the control features are exactly the same between both units. As a matter of fact, Morningstar came out with the ProStar MPPT first, and then pretty much took that control chip and those control features and pushed it back down into the ProStar to create the ProStar Gen 3. The ProStar Gen 3 in terms of the transistors and other stuff is very similar to the Gen 2, but all the control features came from the ProStar MPPT. So they share that in common. So it doesn't really matter which one you're using. All these features we're going to talk about are pretty much the same between either of them. It's only the control methodology, whether you want the PWM or the MPPT, it's the difference between the two. Okay. So again, for the MPPT, it is a 12 or 24 volt auto detect. The other difference is that as the PWM was limited to 60 volts, which is more than adequate for a 24 volt system, because the MPPT can take a higher voltage input from the solar array, its max input array voltage is 120 volts. It does have the same operating temperature of -40 to +60, and it does still have a low self-consumption of only about 0.6 watts under normal operating conditions, which is pretty low for a charge controller with an MPPT. Here is a slide with a whole bunch of circuit board stuff on it. I'm gonna let Brad talk about briefly.
Sure, I'll touch on this a little bit. Thanks, Rob. This is a deck that actually shows a lot of the internal features and components of the products. You'll see that Morningstar's marketing team has provided some great resources like this to really give you a view of what goes into the technology of our products, because it's just as much about the digital and the software as it is about the mechanical. So you'll see several of these for our featured products like the ProStars and TriStar PPTs, as well as videos that give you a walkthrough. So as Rob said, I won't dig into too much detail, but we just wanted to highlight this and some examples of where you can see into the guts of what makes the Morningstar products unique is that, for example, on the left there, the high frequency design, you can see we use very small inductors that operate at very high frequency, and that's what gives us the really tight control of speed and battery charging that you'd expect in the products. And with that comes a lot of capabilities with the ARM processor line. We use a lot of very advanced processors for that type of control. And, that along with lightning protection and some other benefits on the circuit board there are things we like to highlight. So look for these types of banners and displays and data sheets that are available for the products in depth on our website and on our YouTube channel as well. Okay, thanks, Rob.
Thanks, Brad. Okay, so we're going to go into the basic features of the ProStar. And again, these all apply to both the MPPT and the PWM. Okay, so they both have got the 4-stage battery charge algorithm. They both have a local temperature sensor that's built into the circuit board of the unit. They have temperature compensated charge algorithm based upon that local temperature sensor. We've got adjustable set points via dip switches. We've got low voltage disconnect. We have simple lighting control. That's just a dusk to dawn. That's it. We'll get into the more complicated lighting control as part of the advanced features. Okay, we've got some LED indicators. And again, the LCD display is an option for both of the MPPT and the PWM. And they both have data logging up to 256 days. After that, just to mention the data logging at 256 days, once you go past that, the older data is written. So it's always the most recent 256 days. Okay. And this is just the typical battery charge algorithm for most of the Morningstar products, and just about all of them. You pretty much just go in the nighttime mode, and from there you go in the bulk charge until the batteries reach the absorption voltage, and then you hold absorption for a set amount of time, typically 3 hours, but that is adjustable. We'll talk about that. And then you drop in the float mode, and you can pretty much stay there until you hit nighttime again. Equalization is an option. You can go into that as well. And we'll mention some of those settings here as we go along. Okay, the dip switch settings are the same for both the MPPT and the PWM, except for dip switch 8. And I'll cover that when we get to dip switch 8, but I'll go through them in detail. There are 8 dip switches in total. Okay, and dip switch 1 is for whether you want lighting control or not. Okay, if it's off, you're just doing normal load control. If you turn it on, then we're lighting control, and that's simply just dusk to dawn. Again, if you want a more advanced lighting control, that's one of the custom advanced features I'll talk about in a little bit. Okay, number 2 is for dip switches 2 and 3 are for voltage settings. If you just leave them both off, it just auto detects. But for some reason, if you want to fix it, you can. You can set it for either 12 volts or 24 volts. Okay, dip switches 4, 5, and 6 are for charge control. So you've already got 7 settings for charge control, which is, you only had 3, by the way, in the Gen 2. Okay, so now instead of just just 3 settings in the old Gen 2 controller, now you've got 7 in the Gen 3, and then on top of that, you have a custom setting. So if all of the dip switches are on, you go to custom mode, and we're going to go into custom mode a little bit later. Okay, so again, these are all the presets, so you don't have to go into custom mode. typically, I think 90–95% of the time, this will pretty much work for most of your presets. If you've got a lithium battery that needs custom settings, then you might want to use type 8, and we'll go into the custom settings details again here in the advanced settings. Okay, switch 7 is for equalization, whether you want to do it manually or auto. And then switch 8 is, again, the one that actually changes depending upon the charge controller you have. For the PWM, it can disable the PWM. I mentioned before on the Gen 2, you had to like cut a trace or something like that. It got kind of complicated. Now you just throw a dip switch. And I think the normal switching, and Brad can correct me if I'm wrong, but I think the normal frequency switching on the PWM is rather low. It's in the few hundred hertz range or something like that.
Yeah,
The
it's
slow
300
switching,
actually, 300
300.
hertz.
Okay.
Yes.
I thought it was 400, but okay, 300 in that range. Slow switching is basically 1 hertz. So that means it's basically you've gone from 300 hertz to 1, which is every second. So that's quite slow switching. So if for some reason, and I'd be surprised just if your radio had a noise issue, but if for some reason you have a noise issue with the PWM, you can go ahead and use that switch to disable that, essentially turning the PWM controller into a series regulator, which is more of just an on-off type regulator. And that would, again, at 1 second, you're not going to have any noise issues whatsoever. Now for the MPPT, that basically goes from MeterBus to Modbus. And that's important because the MeterBus is used if you want to use the remote display unit, but Modbus is used if you want to use the EMC1. So that's what that switch does on that unit. Okay, let's talk about the LED indicators a little bit. And again, these actually pack quite a bit of information, both in their normal state and also in their alarm error state. I'm going to go into that just a little bit of detail again. And again, by the way, all of this stuff is in detail inside the Morningstar manual, and also a lot of their tech notes on their website. So for some of the stuff in more detail, please feel free to go to the website and dig up whichever topic you're interested in. But let's start with the status LED. Again, both units have got 4 LEDs total. One is the status LED, that's the status of the charge controller, and then there are 3 for the battery state of charge. So for the status LED, if it is off, that means it's a nighttime mode. If it is green, if it's charging, if it's red, it's an error. Now, if it's got a flashing to it, that tells you whether it's regulating or not. So there's different, whether it's flashing or not means something else in addition to whether it's just solid. Okay, but generally, if it's green, you're probably doing okay. If it's red, you've got a problem. Now, for the battery settings, that's based upon the state of charge of the battery. So basically, if the battery is close to full state of charge, you're going to have a green solid. If it is not quite so close, maybe about 75–80%, you're going to have a green yellow. If you're going to be around 50% or so, it's going to be yellow. And then if you're probably around below 50%, maybe 40 or so, you're going to have a yellow red. And then below that, it's going to be red. And you're going to start going on the level of disconnect and stuff like that, whether it's flashing or solid. Again, red is never a good thing. Green is always good. Okay, I mentioned those fault codes again on the battery status LEDs. They can be incredibly helpful to quickly determine if you've got a problem or not. And I would highly recommend, as part of the troubleshooting procedure, before you start doing anything else, look at the charge controller and look at the LEDs and see what they're telling you. Because if the battery status LED is red, you know you've got a low voltage problem. You need to figure out why you went in the LVD. Just resetting the charge controller is not going to fix your LVD issue. You've got an LVD because you have a problem with the solar array or with the load, one or the other. So you need to figure out the problem and correct it. Same thing is kind of true here with the other LEDs. If you've got a sequencing red, yellow with green, or with red, green, and yellow, you've got a problem with the load, either an overcurrent or a short circuit. This one is particularly a problem if you've made the mistake of hooking up an inverter to the ProStar, which you should not do. You should hook that directly to a battery. But if you made the mistake of doing that, those generally have a high startup surge to it that would cause the ProStar to go into an overcurrent or an overload situation. And you can pretty much figure that out by looking at that sequence that's flashing. I've seen the same thing happen with some LED power supplies that may have a high surge startup to it. So anything, or a motor or anything with a high surge or high startup to it, is going to should not be connected, first off, should not be connected to the ProStar directly. And if you made that mistake, you'll probably see that flashing sequencing there. That's going to probably tell you that's what that error is. I don't normally see the high voltage disconnect, although there was a problem a few years ago where we had a really horrible cold snap in the Midwest, and that one did come up. And by the way, there's a way to fix that problem too, and I'll go into that in a little bit of detail when we get into some of the advanced settings of the control. And also, I don't think I've actually ever seen a high heat sink temperature, by the way. But there's an error code for that too. Those are just the common ones. There are other ones too if you check the manual. These are just the ones I thought might be of most interest to you. So those are just kind of the basic features of the ProStar. On the advanced side, we've got an optional meter that you can remote. And again, that could be helpful depending upon if you've got, say, an RV application or a mobile or a boat or something like that. Might be nice to have that in that meter panel someplace else. The optional remote temperature probe. Normally, if the ProStar is in close proximity to the battery, you do not need that. However, if it is in a separate box, I highly recommend that you use a remote temperature probe. I've seen several problems from people that put the charge controller in one box and the battery in another, and they actually damaged a very nice set of new batteries because of that. And once they hooked the temperature probe up to it and put a new set of batteries in, they eliminated the problem. There's also battery voltage sense terminals. As long as you size your wires correctly, normally you don't need those, but it does have that feature if you do need it. And again, I've mentioned the customizable battery set points and algorithm quite a bit already. And again, I think it's one of the best new features of the Gen 3 ProStar. Again, great for the new advanced batteries, especially the lithiums. Again, the customizable set points can be done via the screen. I mentioned before how the screen is improved from the old version or via the computer. So you've got a couple options there. And again, I mentioned we can do advanced load control and lighting control, and I'll definitely be going through some examples of that. The data logging, which I also think is huge and absolutely incredible for troubleshooting, and I'll go into that in more detail later. And again, the remote monitoring feature using the MC1 is just amazing because that allows you to do a lot of this stuff remotely, especially the data logging. You don't have to be there right on site. You can download it, look at it, analyze it. Before you even got to the site, you might be able to determine what the problem is, or at least have a better idea what to look for. So let's talk about the meter options. We've got the remote meter I mentioned before, and you've also got an integrated one. Note, you must purchase the unit with the integrated meter. It's not something you can add to it later. You can obviously add a remote meter later, but you cannot add the integrated one. So if you want the meter function integrated into the ProStar, make certain you purchase it with that feature. Also, again, we'll get into more detail, but the neat thing is you can also make set point changes via the display. So I think having this new meter option is really helpful and flexible because, again, it allows you to make changes right there. You don't have to plug in with the computer. The one negative is if you have a customer, you do not want to make changes or settings to it, you probably don't want that feature then. Okay, and again, now if you've got the remote version, you can just simply connect to the terminal. It's an RJ11 connection, and you would just simply plug in. Note, this is the same port also being used for Modbus. Again, this is where the dip switches come into play on the MPPT to make certain you have it set correctly. So the other things that can work on that meter port, besides the meter, is also the relay driver. And I did a whole webinar on that about a year ago. So yeah, you can do stuff with the relay driver too that would allow you to do like generator control based upon settings from the ProStar and all other kinds of stuff you can do with the relay driver as well. And again, there's a whole other webinar on that. But yes, that's another accessory you can use with the ProStar, both the PWM and the MPPT. Now for the Modbus, this allows you to connect to it using various adapters that Morningstar has, like the MSC adapter. You've got the UMC1 adapter, which would allow you to connect with the computer that way. We've also mentioned the AMC1. And again, this can be used for programming the unit via the computer, for the data logging. You could use it for site communications as well, and also to make the firmware updates if you need to make those. And some of those firmware updates do add some of the features. So sometimes there are feature changes that you might want to make a firmware update for. Okay, I mentioned the remote temperature sensor before. Again, it's just simply connects to the terminals there, as shown on the screen, and it's just 2 wires. It is not polarity sensitive, by the way, so it doesn't really matter how you do it. And the standard cable is 33 feet, which should be enough to get you to whatever the battery is. And there is a lug on the end of it. Generally, it is recommended to try to put that in the middle of the battery bank. Generally, and I don't know why, the negative battery post is the one that's recommended. It is not polarity sensitive, so it does not matter, but I've been told that generally the negative battery post is generally a little warmer than the positive. So I've been told that you get a more accurate reading if you do that. I'm not certain why, but I've had battery people tell me that, so I'm going to trust the battery experts on that one. As I mentioned before, there's already one integrated in the ProStar. So if you've got a box sort of like this, where you've got a couple of batteries and you've got the ProStar on a plate above it, you don't really need to use a sensor here because it's all in the same area. It's all the same temperature. But again, if the batteries are a separate box, I would highly recommend using it. Okay, we also have a remote battery voltage sense. Again, this is a feature that I don't typically use. If your battery wires are sized correctly, it's generally not needed. However, if for some reason your batteries are a distance from the controller, or if you've got some type of surge, of motor source like that, where you may have a possible drop or droop in the wires that may affect things, you may want to consider using that feature. Okay, here is the meter map for the ProStar PWM. The MPPT is almost identical. It's slightly different. I'll show you that in just a minute. And yes, there's a whole lot going on there. So I'm not going to spend time going into that in detail, but you can see just how much stuff you can mess with. I mean, everything from load control to communications, charging algorithms. You've got the history data logging in there with graphs. You've got just all kinds of stuff you can control. Just LVD, all kinds of stuff. I mentioned the high voltage disconnect. You can change that in there, and stuff like that. Keeping on, this is for, and again, if there are changes to, sometimes it do make firmware updates to the unit, and this meter map gets updated with that as well. So for the latest and greatest, always go to the website, and the link is down below for that. So you can always have the latest meter map. And again, that's for the PWM. The MPPT is almost identical, except you can see down there the little red box. There's a little red box that handles the MPPT control. And that basically just allows you to muck with it a little bit. I would not recommend that. Basically, the real thing you can do is disable the MPPT, basically turning it into a PWM, but I'm not certain why you would ever want to do that, because if you were going to do that, you might as well just get the PWM unit. Okay, and I mentioned again, I mentioned the charge settings so many times and how useful this is now. You've got 3 different ways to really adjust those. You've got the diff switches I've already mentioned. You've got by the meter, the display in the meter, or you can do it by computer. And if you're going for the advanced settings, the custom settings, you really can only do it by the meter or by the computer. If you want to use the standard settings, just stick with the diff switches. Again, you've got 7 standard settings. That's going to probably cover most of what you're already doing anyway. Okay, just again, another note, in order to use the custom settings, you must have diff switches 4, 5, and 6 in the on position. And again, you can adjust that. You can adjust the standard settings only via the computer or the LCD display. The other neat thing is that Morningstar has done something that I just think is unbelievable. Just about anything that's a variable is adjustable. I am just shocked at the amount of stuff you can muck with. I mean, there's just so many things that are adjustable that you can change. I would say 95% of the time there's no reason to touch most of it, but again, nonetheless, there's all kinds of stuff you can mess with. And if you go back and look at that meter map, again, you can see all the variables you can adjust. All kinds of stuff from absorption time settings to equalization time settings, float settings and stuff like that, not in addition to just the voltage settings themselves. So again, if you were to go through the meter map, you would end up dropping down into the custom settings here, which would that would allow you to custom set either the charging, the load control, communications, or additional advanced features. I'm going to try to go through each one of these really briefly. Okay, under charging, the absorption voltage I mentioned, you can adjust that, the float voltage, the equalization voltage, as well as the time. You can adjust the absorption time, equalization time, and even equalization schedule. So you can adjust all of those things via the meter and the keypad. If you want to do it via the computer, it looks something a little bit like this. Again, where you can go in there and change all the same settings. You can also adjust the battery temperature compensation, which is depending upon the battery may be necessary. Different batteries may like that. Some don't like you to compensate past a certain voltage as well. So you can stop the compensation either on the high end or the low end for a max temperature or minimum temperature. Again, another really nice feature to have. Certain battery manufacturers like that. So again, I mean, there is almost no reason using the ProStar charge controller, you cannot set the exact settings the battery manufacturer wants for their batteries. So if they've given you their charging parameters, you should be able to give them exactly what they want using the ProStar. And again, you can also the float mode settings as well, along with the other charge settings there on the other side of the screen. And going into those again a little bit more via the computer, you've got your equalization as well as your high voltage. And I mentioned earlier, you can actually adjust the high voltage disconnects. But the thing I like to do better is you can just set the max limits, the max limits on the voltage. So in other words, you can this actually is a really handy feature to have, is the max battery voltage. So with compensation, if you're in a cold setting, your batteries might want to go up to say 15 volts in a 12-volt system or 30 on a 24 volt. You may have loads that can't go past 30 volts. This would allow you to limit the voltage on the battery to 30 volts so that you don't accidentally exceed that and damage your load. Really nice feature to have, really useful. And actually, there's a couple ways to do it. You could do it via the high voltage disconnect, or via the temperature compensation. But to me, the easiest way is just to go over here to the limits and just enable that max voltage limit and just set that right there, so it won't go past it. That's the easiest way to do it as far as I'm concerned. Okay, if we go over to the load settings, again, we have a whole bunch of options here as well. And again, this is going to actually get split up into normal and into lighting control. So under the normal, you pretty much just have your low voltage disconnect and your low voltage reconnect, and you can adjust those voltages as you need to. And we'll get into the lighting control in a minute because that gets a bit more complicated. And if you're going to do it via the computer, it kind of looks like this. Again, nothing too complicated. And again, there's that high voltage disconnect feature I mentioned before, but instead of doing that, I'd recommend just limiting your battery voltage. Again, the only thing you got to be careful with that battery voltage is you want to make certain you're still within charging parameter for the batteries. If you make that too low, you may not be able to recharge your battery correctly. So just be careful using that. Like, you might not want to set that at like 27 volts. If your battery wants to be recharged to 28 or 29 volts, that would not be good. But again, setting it to a max of 30 is probably okay. So just double check with your battery manufacturer on that with regards to the max voltage before you start messing with that setting too much. Okay, so let's get into the advanced settings for lighting control. Again, so you've got a couple there. You've got let's see here. Yeah, you can just you can adjust the warning. So basically, you can adjust the LEDs on that and when that might happen, as well as some other. So you can adjust the high on that as well. You can adjust the high voltage disconnect and reconnect voltages. I think I already kind of mentioned that. Okay, let's get to the custom lighting settings. And again, we've got a whole bunch of stuff here now. You've got timers you can work with. You can adjust the sunrise and sunset. You can actually, it'll actually give it a little summary, a little graph summary of how it'll look, and I'll get into some of that detail. You've got multiple channels here with timers and actions and all other kinds of seriously confusing stuff. I'm going to try to simplify that just a little bit as we go through an example here. Okay, so note you still have low voltage disconnect and reconnect. So that still applies to the lighting control. That hasn't changed any. Okay, so you still got those variables in there. Now you've also got variables where you can adjust the threshold for the sunrise and sunset. Those are based upon the array voltage. I would not, again, this is one of those where you probably have too many variables. I have never had to adjust those. I would not recommend adjusting those. Morningstar has figured out appropriate and good default settings for those, so I would not recommend adjusting those unless you have to. So this might be one of those times you may have too many variables, but you do. If you're in an area with a lot of light pollution and you're having trouble trying to figure out when sunset is, you might want to make that threshold a little higher, perhaps, something like that. So it is nice to have that variability. I just wouldn't recommend using it unless you absolutely have to. Okay, so the channels sound kind of confusing, so we're going to try to go through those in a little bit more detail. And again, even though they're saying there's 4 channels, there's really only 2 events. So I focus more on the events than the channels. I try to explain how those work. So basically, the events are basically you've got before sunrise, before midday, before sunset, before midnight, or after, before after each one of those things. I'll try to go through that with an example here in a little bit more detail. Basically the action is to do nothing or to turn the lights on or turn the lights on. And I know it says lights, but the truth is it could be the load. I'm going to go through an example of you may use lighting control for something other than lighting. So again, this all may be a little confusing, but they've got that little summary display. So if you go to that summary setting that I was mentioning earlier under the keypad, you'll see it comes up with something like this that kind of shows you how it works. That little box up above is the trigger. So you can see in this case, in this example, you're going to see that the load's going to come on at sunset and then turn off at a time around midnight and not at sunrise, because that'd be further on down the line. But that's what that is. It tells you it comes on at sunset and then shuts off in the middle of the night. And again, the lighting options here are just endless. If you remember the sunlight controller, I mean, yeah, you had about 9 settings there, which is great, but this is way more infinite. You can give it, 1 hour, 2 hour, before, after, whatever it is. I mean, all kinds of stuff. And the other thing here is that you have options for daytime control now, and that's what I was trying to say before. I know it mentions lighting, but there are now daytime options you didn't have before. There are some places that want construction site cameras that operate from sunrise to sunset instead of sunset to sunrise. Another big application is kiosks. There are kiosks that want only to operate during daytime hours. You could set it for 8 hours a day. You could set up for 4 hours before or after solar noon. There is no real-time clocks. This is not specific. It just operates around the sun itself. So if if you can be plus or minus an hour in your settings, this is a great option. And again, this is an example of 4 hours before or after, but you can do 5 hours before or after, or 6 hours before or after, whatever you want. Again, it's almost endless the things you can do. So, I mean, here's another example that shows the load on 2 hours after sunset and 2 hours before sunrise. And you can see how you can use both of those events to change it. So what's interesting is you can shut it off in the middle of the night. So this might be, let's say you've got some parking lot lighting, maybe as an example, where it's in an office where you've got people that may only work to 8 o'clock at night, and then they come in again at like 6 o'clock in the morning or 5 o'clock in the morning or something like that. You don't need it on all night long. So you want to shut it off in the middle of the night. This would allow you to do that. You can set up that says, hey, I only want the lights on from sunset to 2 hours after sunset, and I want it on 2 hours before sunrise until sunrise type of thing. So there's just another example of how you can do that. By the way, this is the computer image of that one. This is not the display. This is what it looked like on a computer if you did that. And here's a neat example of a sunrise to sunset. As I mentioned before, it operates all day long. Again, if you've got maybe some type of application that does that, and that's something the sunlight controller can't do. So this is kind of a really neat feature. If you need daytime control, you can now do daytime control. Kind of a neat thing you can do. So that's kind of the lighting control in a very quick snapshot summary. And again, if you want more detail on that, I would suggest going through the manual or looking at some of the other things on the Morningstar website, or just emailing us or calling one of the tech support people at Morningstar. I'd be happy to help you with your application in more detail. Or myself, if you also need help, I can also be hired to help you with those applications as well. So let's jump into the data logging. As I mentioned before, the data logging is for up to 256 days. After that, the data is overwritten. It only keeps the latest 256 days. The data can be viewed on an LCD screen. However, I highly recommend you download it and analyze it. Download it, bring it up in Excel or whatever spreadsheet you use, and analyze it, graph, and look at it that way. And I'm going to show you some examples of that. You could do it over the MC1 if you go with that option. If you don't have that option, you can connect up to your computer using the UMC1. You need that adapter to plug into the meter port to the USB port on your computer. So you need an adapter for that. And again, even if you don't, I highly recommend you do that anyway. Even if you do not have an AMC1, I highly recommend you have that cable, and that when you go to visit the site, if you have a ProStar, any version of it, any version of the Gen 3 or the MPPT, because having that data is incredibly helpful. Whether you use it or not, or whether you look at it later, it's just incredibly helpful. So whenever you visit the site, I just highly recommend plugging in and downloading it and just looking at it later. If you want to go through the screen, again, you can go through it. If you hit the history, if you go over the history menu, you've got the error log, graphs, and records. So you can go through that and work your way through the menus to get over to whatever one you're looking at. And then if you're looking at it, a history record, you'd look at a battery voltage chart that looks something like this. It'll give you kind of the min and max over the days. Okay, so now when you connect up to a computer though, it's automatically downloaded. So as soon as you connect up to the ProStar, it's going to automatically download. It's going to save any file that is stored on your computer under users, and then the username. Like for instance, mine is Rob Rallo, so it'd be users Rob Rallo /appdata/local/Morningstar blah 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 blah. Okay, and then it's also saved with the controller name and number. An example of that is down there. For again, this example would say PS-PWM-30M- and then the serial number. Okay, and again, this is an XML file, I mean, which is basically, it's a comma separated variable, and you can import that into pretty much just about any spreadsheet like Excel. I typically use Excel, so just keep coming back to that one. Be aware, important note on this, the app data folder is typically hidden by default, so you may not be able to see this. So if it is hidden on your computer, you need to go into the Windows and modify your view such that you can then show hidden items and you'll find it. So just be aware that if you can't see it, it might be because you have your app data folder set up to be hidden. Okay, so just keep that in mind. Okay, and as I mentioned earlier, once you've downloaded the file, it's pretty easy to bring it up in Excel and analyze the data and everything else. One thing to note, I mentioned this before, there is no real-time clock on the ProStar. So what ends up happening is that when it's downloaded on their computer, it does some calculations to work backwards, so it figures out what the current date is, and then it kind of works backwards and figures it out from there. So the data is then based upon that. Okay, and then for those that are really curious, the date and time is in an ISO 8601 format, and it's also done in UTC, which is Coordinated Universal Time, also formerly known as Greenwich Mean Time, for those that like that kind of key detail. And again, there's also once again, if you really want to learn this stuff in detail, there's a tech note on the Morningstar website with that information as well. But let's get into the good stuff. This is an actual log file from a site, and those dates are correct and accurate. This came from a client of mine that allowed me to use this data with their permission. This site is in California. It's actually used for sign lighting. So they're lighting up a sign from it's set from dusk to dawn. So actually we didn't use the custom settings. We didn't need to. We just used that standard dip switch 1 to set it up for that. It's also a 12-volt system. This site was actually rather large, and there's actually 2 ProStar MPPT 40 charge controllers in parallel. The neat thing about this is we were actually able to download data from both the charge controllers and analyze them against each other. So it's just kind of neat to compare and make certain everything's coming up the same, which it did in this case. Okay, so also what's interesting here is I'm showing kind of the worst case of the year, which is typically around December 21, 22. That's the shortest day of the year for North America. So it's generally we're going to have the least amount of sunlight. So being able to download this and look at it can be incredibly helpful because you can see what's going on. So just to kind of run through this real fast, again, you've got several headers. I'm just going to try to run through it real quick. You have alarms daily. The RTS open is because I did not use the remote temp sensor because these charge controllers were installed in the same box with the battery, so there's no reason to have the RTS. So it always came up with that. You'll notice here that there were no load faults, no array faults. You can see that the battery got down to as low as about 12.3 volts or so, maybe a little lower there on the 17th for some reason. Probably had some clouds that day. You can see how high it got. What's most important here I find interesting is that you want to look at the absorption time. And I think for some reason this one was in seconds, not minutes. I think that may have been a firmware change they did later on. But you can see that absorption time. And you're looking at it maxing out at around 10,800. And you'll notice there's an equalization time. I was using valve regulated batteries and did not want equalization. But if you're getting into absorption on a daily basis, that's what you want to see. That tells you your batteries are getting fully charged. Then we even have float time. Again, that column all the way to the far right is the time for float daily. So that's how much time you spent in float. So if you're getting the float, you're doing really well. So this tells me that my site has plenty of energy. My solar array is charging my batteries fully pretty much almost every day. We're getting through the absorption time, getting in the float time. And this is the type of stuff you can download and analyze because this tells you your system is healthy. I'm going to show you what happens if your system is not healthy in just a second, because unfortunately at this site, there was an incident and we were able to go back, look at these log files to figure out what the incident was. So you'll see here that on January 20th, there was an incident. We don't know what it was. And all of a sudden, everything went haywire. We had an LVD. We pretty much had an LVD every day after that. Then we had this F10 supply out of range. Basically, that meant that our system was dying every night severely, such that it was causing the charge controller voltage actually to end up out of range. And we couldn't figure out what happened. There was nobody on site. This all of a sudden happened. It was a total mess. You can see that. And what's weird is, this is where it got really bizarre. We were still getting into absorption time daily. Now, you'll notice you never made it the float time because there's another setting, by the way, under custom settings that says, hey, if your battery voltage drops to such and such a point, then you go on the absorption for longer. So this charge controller was going down the LVD every night, and yet it was getting an absorption every day, telling me that my solar array wasn't the problem. And it seems like the system, the batteries were fully charged. So we're going, what's going on here? Why would my batteries go into LVD every night, and yet it's saying they're getting fully recharged every day? Well, lo and behold, what had happened was this site had 3 12-volt batteries. One of the batteries failed. And this is a great indicator of a failure of a battery. If you see your voltage, if you have wild voltage swings like this, that's indication of a battery failure. Now, what's also interesting is these batteries were only a year and a half old. They were only 18 months old. Okay, and the warranty for the battery was 24 months. So by going back to the manufacturer, showing him this data, giving this data to the manufacturer and saying, hey, look, we were fine up to this point. You can see the batteries are fully charged. They were getting an absorption of float daily, blah, 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 blah. And then all of a sudden on this date, we had a problem. The battery manufacturer said, yes, we replaced that battery under warranty. And as I mentioned earlier, batteries are very expensive. It is probably the single most expensive component in the system now. It's about 40% of the cost of the off-grid system. So by having this data and being able to hand it to the battery manufacturer, they were able to have the warranty honored and have the batteries replaced. Not just that battery, actually all of the batteries, because they all got damaged once the one went. And again, that could have been rather expensive, but this data from this charge controller was able to do that. Also, to let you know, this was not a EMC1 situation. They had the client had to plug into it with his personal computer, which he did to get this data out of it. But again, you can just see how important this is to be able to do that on a regular basis, because you never know when this could be helpful to troubleshoot the system, and even at this point use it as a warranty claim to replace those batteries in the warranty. Also, neat, you can also look at the graph here if you want to. Again, you can see on that January 20th, that huge dip down, and how it was a problem from there on after that with all those huge swings and spikes. So just interesting to see. This was actually the aggregate of both charge controllers, which you're looking at there. Something else you can do too. Again, this side had 2 charge controllers, so you were able to bring both the data from both the charge controllers into Excel, and then you were able to do a third sheet essentially. Yeah, one sheet for one charge controller, a second sheet for the other, and the third sheet where you added it all up and summed it so you can look at it together as a whole pretty well. So just another great example of that and how powerful the data logging tool is for maintaining and checking the health of your system. So that being said, I know we've covered a lot of information in a short amount of time. Again, I hope you picked up something, you learned something new. Again, there's lots more information in the manual on Tech Notes on the Morningstar website. And again, I thank you for your time, and I hope you learned something new about the ProStar you didn't know before. So with that said, I think we have a few minutes left for some questions.
Great. Thanks very much, Rob. That was excellent. And yeah, I just really want to concur with you that, being able to analyze the data can really unlock, the answers to some really difficult questions. And you just don't know, what has happened at the site without that information. As we see more uptake on the IP-based communications, obviously the internal data logging is excellent because it's always in the controller and it's stored in flash memory. So it's always going to be non-volatile. But as we see more cloud connected devices, we're seeing a lot more data in real time, and it really gives you a lot of insight. So I'd like to, so again, thank you very much for that, Rob. And I'm going to go through some questions here. I've been kind of keeping an eye on them during the presentation. I can see that you've been stimulating some minds because as you hit certain topics, the questions sort of come into play. And I would ask anyone else to go ahead and type some in there. First, let me start with one I'll take that kind of covers a few. Some questions about the battery customization and lithium support. As Rob had mentioned during the presentation, we have that customization of the set points that can be done. That can be a change on the meter display. It can be a change using the software, and you can even load a saved preset. Morningstar has a program called the Energy Storage Partner Program, which has us working with a variety of the industry-leading manufacturers in both lead acid and lithium, with an emphasis on a lot of the newer lithium batteries. And what we do is we have those batteries worked out in terms of common ground and communication with the manufacturer on agreed upon settings that are then put on our website for that battery and for all of our products. And that takes a lot of the guesswork out. You can customize it from there, but that's a great way to get started and get you into lithium systems by having those custom settings ready to go. And there's also a lot of good support information on there. The other thing that often gets asked is, what is the best setting for certain batteries? And often that is, involves looking at, the data sheets and really looking at your system. And as Rob's providing system design solutions, he can provide a lot of those answers because it's really not always just a preset. There's some things you need to take into account with the size of your system and temperature. So with that, one of the questions, and I'll pose this to Rob, is because I know you've got the experience in the industry there. We have an application where there is a system, and I can actually read it here, a system in Alaska where the minimum temperature may go down to negative 55 C in some locations. And they wanted your thoughts on what are some things you can do to address that, and is heating required in a system of that type?
Good question. I would not recommend heating actually, um, because that just is yet another load and burden for the system. Now, if minus 50 is your absolute, there's a good chance that there's going to be a little bit of heat in the enclosure itself. So you may want to try to insulate the box and have the little heat you can get from the batteries and the charge control and the things. Try to keep that box warm. But try to keep it above 50 C and into the 40 C range that the charge controller will want. Now, along with that, now you would definitely need to derate the battery substantially. I would look at the battery manufacturer's derate chart for temperature. And because of that temperature, it may only have, I don't know, 20, 30% capacity. So you may have to actually make your battery 4 or 5 times bigger to compensate for that. The other thing, I would definitely look at the charge parameters for that battery. And there's a good chance the manufacturer may tell you to not compensate past like -10 or -20 C. And then you can also adjust the settings for that to happen. As I mentioned, there was a back there on one of the slides. There's a couple of places where you can limit or set that minimum temperature compensation. This would be a great example of that, because you don't want to start charging your batteries to say, 16 volts or something like that. You may just want to keep that limited to 15. So another good place to do that. But that would be my thoughts and starts on that. That's where I would begin. I would probably need a little more details to go of the application to go further in detail, but I would start by looking at those things.
Yeah, and our products, as you saw on the specs, they do operate down to -40. To be honest, really what the main factor there is often just the LCD gets a bit sluggish. It's kind of hard to transition when it's that cold, but the products, we have a good history of them operating to those really cold temperatures. They will self-heat a little bit. So as Rob said in the enclosure, you're typically okay. But yeah, you definitely, the higher state of charge you can keep that battery, the better, because the lower it is, the more it's like water. And we all know water freezes, so be very careful there. Let's see, I had a question on, can we use lithium batteries with the ProStar? One of the advanced features that was covered in the presentation there that Rob was talking about is there is a setting called lithium foldback that is not only allows the preset to be loaded into the product with our ESP program, but you can also set in those low temperatures current limiting so that you're also not charging lithium batteries below a certain point, which is really what they require for the specs. Here's a question, Rob, on data logging, since you spent a lot of time with getting files exported. In the case of, let's see here, let me pull this and read it word for word here. 1 second. Data log has to be reset in early January to correct for skipped days around December 21st in Alaska. As we know, Alaska's got a little bit of a different day-night cycle there. I manually reinsert data to the Excel file. Is there any better solution to account for that those missing days?
That is a great question. I have no idea, actually. I have never encountered that one. I hadn't thought about that, but yeah, you've got places in the world where there is no sun occasionally, and therefore the charge controller doesn't know. I don't know. That's actually a good question, and something I had not considered or thought about, and I'm a little stumped on that one.
Well, I was going to say I'll definitely drop a note into the product feedback because one of the things I can mention, I hate to talk about future products not on the market yet, but a lot of our products going forward now, you're going to see that they, even though Rob said these products don't have a real-time clock, you'll see a real-time clock coming into some products that are coming in the near term, and they will not only have the ability to get network time and also be set to have a clock that will keep time regardless of day-night cycle, but they'll even have a coin cell lithium backup so that if power does get disconnected, they'll maintain that time setting. So hopefully look for that in the future. Let's see, a couple other questions here. One moment. Rob, there was a quick question from a couple participants. They just asked simply the difference between increasing amp hour capacity with a battery when you stack them in parallel versus stacking them in series. Is that something you could address at the system level?
Yeah, when you put batteries in parallel, the amp hours would increase. You do not want to put batteries in series for amp hours. You put them in series for voltage. So if you had a 12-volt battery, you're working on a 12-volt system, you would put more 12-volt batteries in parallel to increase the capacity. So if you had a 100 amp hour battery and you wanted 200 amp hours, you would just put two in parallel. Now, if you wanted, if you're using 12-volt batteries and a 24-volt system, then you would put two batteries in parallel to get you 24 volts.
Okay, thanks, Rob. Here's another good question on talks about mounting products inside of an enclosure. The products in question are the Sunsaver MPPT and a ProStar Gen 3. And it's a two-part question. First, they ask, are there DIN rail mount options for the ProStar 3? And second, are there any concerns with mounting either of those products inside of an enclosure that has vents but no active cooling?
Um, No, there isn't it's a good question. There is not a DIN mount option, although I do know some integrators that actually created their own DIN mount bracket for the ProStar. I don't want to call them out necessarily by name, but I do know of at least one one integrator that has their own custom-made bracket for that. But it is not DIN mountable otherwise, unless you want to make a special bracket for it. Actually, Brad, I think you and I talked about that about like 10 years ago, actually, or something like that, I think.
Well, it's funny because I'll just mention that one of the reasons we have DIN rail mount brackets for the Sunsaver line is actually based on a lot of feedback from Rob. So he can tell you how much notoriety he carries around here. So I got to give
I,
you credit for that.
I could actually,
Um,
I could tell you, I was the one who actually changed the name of the TriStar, because originally you guys were going to call it the GenStar, and I got on. That was back when Ken was alive, and I said to Ken, I go, "Is it Gen? Is it does it do generator control?" He goes, "No." And I go, "Well, I call it the GenStar," and that's
yeah.
how the TriStar was named.
Yeah. So one other item here regarding it, heating and cooling in an enclosure. I will tell you this: we have documentation and we have a lot of experience in system and application support with cooling or keeping products. I guess I should say not cooling. It's not an active cooling, but without them overheating in an enclosure. Generally, the efficiency is pretty high. They will self-cool with just convection quite easily because the efficiency doesn't produce a lot of waste heat. As long as they're not mounted right at the top of the cabinet, you're generally okay. We can refer you to some application design and support documents from some of the enclosure companies that will allow you to calculate heat generation in watts. Morningstar can help you with that as well. And you'll often find that even in just a vented enclosure, your heating is typically fine if you give it adequate space above the product. It's really only in really high power 10, 20 kilowatt telecom enclosures where we ever run into active cooling needs where there's like actually an air conditioning or fan that has to force air out of the actual product. So, okay, let's see. With that, I think I can just cover one more question here and then we should wrap up since we're a little bit over time. Let's see here. One question is regarding I'm working on a system and would like to have remote control features integrated. In other words, data logging and system control remotely. How can I get these? Who can I talk to get these set up, these components set up and configured? And what I would say is that if you are doing remote control, bidirectional setting changes as well as logging, definitely you can reach out to us at Morningstar and we can point you in the right direction. We have our EMC product, which will give you some connectivity options on the internet. When you get to the point of needing an internet gateway or wireless connectivity, such as a 4G router or cellular access point, that's a little bit beyond our scope. Rob, I think you've covered a lot of remote applications. Do you have suggestions on remote wireless connectivity and where to get assistance with something like that?
Yeah, I do. I just say contact me. My contact information on the screen right now, and I could help you with that. I've got several clients I work with that provide that type of product. They can provide remote Wi-Fi, cellular modems, as you mentioned, and several other remote communication options.
Okay, great. Okay, thanks very much. There are a few more questions on there. We're over time, so what I will do is we will be able to get through those questions and get replies back to you. So if we didn't address your question verbally during the presentation, we will respond to you and follow up. And as I'll say again, we are here to help you. Part of unlocking a lot of the value of these off-grid sites is not only designing them well, but also a lot of these tips and tricks that Rob was able to talk about with on the presentation, because when you've covered that many systems, such as daytime operating loads for kiosks and other things, that experience really helps you to design better and better systems. So I'd encourage you to reach out to Rob at Solar System Services, as well as Morningstar for either system level support or Morningstar product support. Okay, so we will address those remaining questions, and with that, I will go ahead and thank everyone for attending. Rob, any final words from you there?
That's it. Thank you again. Thank you, Morningstar, for allowing me to speak and hosting this. And again, I hope everybody learned something new about the ProStar.
Okay, yep, definitely. Thank you very much, Rob. And thank you, everyone. And we'll see you again for the next presentation. Take care. Have a good afternoon.